Welcome to the channel Tribe. This episode is a part of our webinar series Tribecast. In this episode, we are having James Bach talking on the topic heuristics and why testers should care about them.
Okay, folks, I'm going to start now. I hope you can hear me. Perhaps somebody can confirm in the Zoom webinar chat that my voice is audible. And okay, we're going to go. Well, I want to talk today about heuristics. Maybe that's a word that you've heard before. Maybe it isn't, but it's a word everybody should know about, and especially all testers should be very familiar with. It's fundamental to all of my teaching and consulting and my entire approach to testing. So I'm excited to share that with you. So here's the context for this. Oh, about 30 years ago, more than 30 years ago, when I was young, I wanted to be good at testing. I wanted to be very good at testing. I fell in love with testing, and I wanted to get as good at it as I could get, as fast as possible. Well, here were the options that I knew about. I knew that if I had a supervisor and the supervisor was an expert in testing, the supervisor could tell me what to do. If I had a lot of natural talent, then I would just be good at it. If I waited long enough, I would probably get good at it just by trying to do testing for a long enough period of time. I could train myself or become trained. And I understood training to require disciplined practice. I later found out that there's a term for this. It's called deliberate practice, skill developed through conscientious trial and experiment. I could do that. Or I could follow procedures that were given me by someone else or that I wrote down and followed with discipline. These were the options that I think that I had. And the problem is none of them worked for me. I didn't actually have a supervisor. My boss didn't know much more about testing than I did as a new guy. And anyway, he had other things to do. And I think a lot of testers have this problem that they work for people who don't know much about testing. And even if they do, don't spend a lot of time telling them how to do it. I might have natural talent as a tester, but I didn't want to rely on that. I didn't want to wait for experience. Experience takes too long to get. I'm happy to do deliberate practice, but I wasn't sure what I was supposed to be practicing. And whenever I tried to follow procedures, it felt wrong. It felt stale. I felt like I was doing bad work. And anyway, I found I don't like following procedures. It's a different mental state I get into that's not any fun. So none of the methods that I knew about seemed to fit what I needed. So there's something I didn't know. What I didn't know at that time is that there are two other mechanisms that can allow you to become very good at technical work. I also didn't know that these are intuitive mechanisms, that they're built in to our human minds. So you're going to use them whether you know about them or not. But what I found out is if you use them deliberately, they become very powerful. And those two things are mental models and heuristics. And those are the methods that I used to develop in my craft. And I could have saved several years of essentially wasted effort if I had known about this right at the beginning, if someone had told me. So I'm telling you. Now, this is so important. I'm going to make these things kind of flash. I'm going to put angels on the screen and have them fly around because you really need to know these things are important. If I look back over my career, I would say that learning about these things was a key thing for me. Now, this presentation isn't going to be about mental models, but I want to say a few things about them because they relate to heuristics. When I'm speaking of mental models, I'm first speaking of models. And a model is something that represents something else. It's not entirely what a model is, but it's pretty close. It's a nice, simple definition that fits in almost every situation. And what you see on the screen here is one kind of model. This is a formal model. This is a UML type model. But there are other kind of models. I mean, there's an airplane model there. That's a model. It's something that represents something else. Here's a model of a hurricane. That's not the actual hurricane. It's a model of a hurricane that's on a screen. Fashion models, of course, are models as well. Mathematical models are models. All these things are models. But none of those things I just showed you are mental models because I can't show you a picture of a mental model. It's inside your head. A mental model is structured in the state of your brain, the state of your neurons, and it ends up being a mental picture or a mental understanding of something that's your model of it. Once you have an understanding of something, it's a little structure that you carry around with you that represents that thing in your mind. And by working with that thing, you are able to work with the real thing. That's what a model does. A model is a representation of something that allows you to work with the real thing. So there are other examples. The easiest example probably is a map. If you have a map of a city, then you can navigate around the city. And the map of the city is a model of that city. Now, why models are so important is that as a new tester, one thing I now know that I needed that I didn't know at the time is I needed to get a mental model of software testing in my mind, a mental representation of the software testing problem. Once I have that mental representation, then I would be able to understand testing in any situation I would find myself. And that brings me to heuristics. A heuristic is defined as a fallible means of solving a problem. Now, that definition is my definition. I came up with that definition. And the reason is because I have been unable to find anyone else's definition of heuristic, which actually represents what a heuristic is. What I mean by that is I have studied many books and papers over the years on the subject of heuristics, and I see how the word heuristic is used in the worlds of engineering and psychology and the philosophy and study of science. I see how the word heuristic is used, but very few writers even try to define the word heuristic. And those who do define it, it seems to me they get it wrong. So this is my definition, and it's a beautiful, simple definition. And this definition is all you need. A heuristic is two things. It's a way to solve a problem, and it is fallible. And by fallible, I mean it might not solve the problem. Now, some people say that heuristics are means of solving a problem that's based on experience, but that's not true. In mathematics, heuristics are never based on experience. Heuristics are based on mathematical models. They're formally based. They're mathematically based. That's not experience. And some people say that a heuristic is an approximation of a solution. But a heuristic can be incredibly precise. It can be perfectly precise in its suggestion of a solution. For instance, you might have a heuristic for choosing lottery numbers for winning a lottery, and that heuristic might work 1 out of 100 times, but when it works, it gives you the exact lottery numbers that you need in order to win the lottery. Well, that's a heuristic because it can fail, but it's not an approximation. It gives you the exact result. So a heuristic is not necessarily an approximation. It's also not necessarily just a good enough answer. It might be a perfect answer, just an answer that it's not guaranteed to give you. Heuristics aren't necessarily ideas, although many heuristics are ideas, and many heuristics are processes, but not every heuristic is a process. So I'm going to give you some examples, but the thing to remember is a heuristic is simply any way of solving a problem, any means of solving a problem, which can include objects, which isn't guaranteed. It's a simple definition, but the implications of this definition are profound and far-reaching. So I want to get into those. Here are some interesting kinds of heuristics to broaden your mind on this. A hammer used by a carpenter to put nails into wood is a heuristic. That's because a hammer is a solution to a problem. We want to get the nails to go into this wood, and we try pushing them in with our fingers, and that doesn't work very well. So I know we'll hit it with a rock. We'll hit it with a hard object. Oh, look, that helps. Well, we'll design a better system for doing that. And the result of that is a hammer. But it's not guaranteed to get the nails into the wood. Then you can use the hammer incorrectly, and the nails will bend, or they won't go in, or you'll hit your thumb instead of hitting the nail. A hammer's not guaranteed to work. And if you're trying to put screws in instead of nails, well, it certainly won't work to get the screws in properly. So not only is a hammer a heuristic, but every tool that a carpenter uses is a heuristic, even though it's a physical object as well. Some heuristics are designed to wake you up in certain circumstances. We call those trigger heuristics. Some heuristics are designed to convey lots of information to you. Those are called radiator heuristics. Like a chart with data in it is a radiator heuristic. It's solving a problem. The problem is getting you the information you need to solve to do something. And a radiator is an imperfect way of doing that. I mean, it radiates data to you, but it might radiate it incorrectly, or you might misunderstand it. Decider heuristics or decision heuristics are ways of deciding what to do. For instance, a simple example is if you're driving and you see a green traffic light, that means go. Now, it's a heuristic because it might not solve the problem. You might drive through the green light and somebody else runs the red light and they smash into you, thus failing to solve the problem of getting through that intersection. But it's a pretty good heuristic for deciding that it's safe to go. A policy is a decision heuristic that you are committed to. If we decide to use a decision heuristic no matter what. We're committed to it. We call that a policy. Policies, for instance, policies in your company, policies that are set by your management, those are heuristics for managing your organization. Test cases are heuristics. Every test case that you've ever written, you've ever seen, you've ever performed is a heuristic for finding a bug. It's not guaranteed to find a bug. No test case is guaranteed to find a bug. If you already knew there was a bug there, you wouldn't need to run the test case. You only perform test cases when you think there might be a bug there. And if you're wrong and there's no bug there, well, then in a sense, you've just wasted your time by running the test cases. So that's what I mean when I say it's heuristic. That's one of the things that I mean. It could be a heuristic in many ways, but we never know for sure if we need to perform a test. We never know for sure if the test will result in completely useful information. The whole nature of testing itself is heuristic. Habits are heuristics. A heuristic that you normally use and no longer question becomes a habit. And I have many habits of testing, things that I do that I no longer question, things that I do to warm up. My habit in testing is the first time I see an application, I want to overwhelm it with lots and lots of input. That's a habit that I have. I'll use that. I'll do that even if I have no good reason to believe that's an important test. Well, it's okay. It's a habit I have. And the thing about a habit is that might solve a problem. If you gain a habit, then that lowers the cost of remembering to do a particular technique. So habits themselves are heuristics. Neural networks are heuristics. The neural network that is your brain is itself a heuristic. And also neural networks that are used in machines are heuristics. They operate based on statistical patterns. Those statistical patterns aren't guaranteed. And so you can fool a neural net. And that's one reason why optical illusions exist, because our eyes are operating based on neurons, and the neurons are making lots of guesses by their very nature about what's happening in the world. So you might have gotten the impression by now that everything is a heuristic. And I understand that. So it helps to think about what's not a heuristic. Here's an example on the side here of long division. The process of long division, a process for dividing one number by another number. In this case, dividing 75 by 3, you get 25 if you follow the long division process. Long division is an algorithm. It is guaranteed. If you are following the rules that long division requires you to follow, if you establish the preconditions that long division requires you to establish, then it is guaranteed within that set of rules, which is a formal system of rules. So that's not a heuristic because it's guaranteed. But notice that guarantee only goes to the boundaries of that formal system. It doesn't go outside that. So long division is an algorithm and it is not a heuristic. However, can algorithms also be heuristics? And the answer is yes. You can take long division and you can use long division to solve a human problem. And let's say that problem is dividing up a restaurant check. So forgive me for using dollars. I didn't have time to research what things cost in India. But in a big city in the United States, if you want to go out and have a nice big steak or something, or a big expensive meal, well, that's going to cost you a lot of money. It might cost you $72. Now imagine that you have two people who've come with you to dinner. One has tea for $2. The other has a water for $1. If you split that check 3 ways, each person pays $25. So that's using long division, but it's using long division as a heuristic, not for dividing numbers. It's not a heuristic for dividing numbers, but it is a heuristic when you say, what would be a fair way of deciding who pays what when you go to a restaurant? So you see, you can have an algorithm that guarantees one thing, but it doesn't necessarily guarantee that it will solve the problem that it's being asked to solve. And in which case it becomes a heuristic. So an algorithm can also become a heuristic depending on how you use it. So this is the fundamental truth. Anything that is used as a heuristic is a heuristic. A heuristic is characterized not by what it is, but how it is used. And this is the beginning of the profound implication to testing and to technical work that heuristics represent. Because at this point, you ought to be asking a question. If this is your first time thinking about heuristics, the question you should be asking is, so what? Who cares? All right, sounds like everything is a heuristic in engineering, James. Okay. But if everything is a heuristic, and if we already do engineering, then why do we need to study heuristics? Apparently, we already use them all the time. So what difference does it make? How does calling things a heuristic make them any different? How does that help us test better? This is a question that ought to be occurring to you right now. So I will answer this question. When I realized that everything is really a heuristic in testing, and that algorithms were not the basis of testing, but instead heuristics were, this is how it helped me. First of all, I stopped wasting my time looking for best practices. I was looking for algorithms for the right, correct, universal way to test. And once I realized that it's all about heuristics, I was released from that fruitless search. I knew that search would come to nothing. So I saved my time and stopped wasting it. There are no best practices in testing. What there are heuristics. When someone says they have a best practice in testing, what they mean is they have a heuristic that they really like, but they don't realize it's a heuristic, so they don't realize it can fail, so they're not ready for when it fails, so they're not very good at being a tester. As soon as you think you found the one perfect way, the one perfect technique, you've abandoned good testing, it seems to me. I realized that testing cannot be automated because it's based on heuristics, and heuristics require human judgment. Think about it, if heuristics are fallible ways of solving problems, then that means you can't just let them go by themselves. You have to guide them. You have to shape them. You have to know when to use them and when to stop using them. Humans are at the center of technical work. Human judgment drives everything. If your technical process is a high quality process, if your technical process is responsible, then human judgment is at the center of it. So that means I can't automate testing. What I can do is use automation as a tool the way a carpenter uses a hammer as a tool, the way a carpenter uses an electric drill as a tool. I can use automation, but I keep track of it. I watch it. I monitor it. I manage it. And that's what makes it okay. So it's not really automated. It's partially automated. Once I realized that heuristics are the key thing, then I started discovering heuristics. I would notice patterns of problem solving that I was using or that other people were using. I would give a name to that pattern. I would practice using that name to bring that heuristic to mind. I would make lists of heuristics and put them in models, heuristic models, and memorize those lists and practice with those. What I realized is heuristics are everywhere. They're all around us. We're constantly inventing them. But what most people don't do is give them names and record them and practice with them in a deliberate way. That's what I started to do once I realized that heuristics were the key thing. And I also began to study the dynamics of my heuristics. In other words, when I say study the dynamics, I mean I wanted to know why a heuristic was helpful. Under what circumstances are my heuristics helpful? Under what circumstances would a heuristic stop being helpful? If you know you're using heuristics, then you know they could fail. So you are now responsible for discovering when they fail and stopping them when they are not helping you. So you're now in a very active role, which is different from following a procedure. It's different from doing what you're told. It's different from thinking in terms of best practices. And so I felt more in control because heuristics are always subordinate to people. The practitioner is in charge. I am in charge as the tester. I apply my heuristics. I like to say that you don't follow a heuristic, you apply a heuristic. A carpenter doesn't follow his hammer, he uses his hammer. And I use my heuristics. That's a little different attitude than following procedures. If I follow a procedure, it's because I've chosen to apply that procedure at that moment. So I use my procedures heuristically. Let me give you an example. Here's a testing heuristic. You probably haven't heard of this before, but when I tell you about it, you'll recognize it. I call it the perimeter assumption. The perimeter assumption goes like this. If things are okay at the limits, then things are okay within the limits. That's the perimeter assumption. And the perimeter assumption is one of the underlying ideas behind boundary testing. Surely you've done boundary testing. Why do you think boundary testing is helpful? Is boundary testing helpful just because somebody told you that you should do boundary testing? You just read it in a book, or they The ISTQB says boundary testing is important. Well, those are all bad reasons to do boundary testing. A good reason to do boundary testing is that you understand what boundary testing is and how it can be helpful. So one of those principles is if things are okay at the limits, then things are okay within the limits. And what that is becomes a heuristic for doing is it helps you solve the problem of where to put your guards if you're guarding an encampment. Well, put them around the outside, because if something's going to attack you, it's going to come from the outside rather than the inside. If everything is quiet out on the sentry posts, then surely everything is quiet inside. Now, from a tester's point of view, this analogy suggests that we should spend time testing extremes. If your product can handle a 100,000 line text file, if your text editor works well with a 100,000 line text file, then it probably can work with a 20 line text file. It would seem strange if it handily allows you to edit something so huge, and yet when you try to load a small file, it falls over and dies. That's what the perimeter assumption is suggesting. Now, this is a heuristic, and heuristics can fail. So if you are a competent tester and a responsible technical person, then you should be able to tell me how the perimeter assumption can be wrong. And that's the key thing. When you know you're dealing with heuristics, when you're responsible about it, every one of your techniques and practices, you can say how it can fail, and you are alert to how it can fail. So how can this fail? Well, there are some kinds of bugs that only happen with non-extreme data. They won't happen with extreme data. They may only happen with a certain combination of data. I want to find those bugs too. It's also possible that when you're using extreme data, you're getting extreme output. And in all of that extreme output, there's buried in it, there's a problem which you don't notice. You would have noticed it if the data hadn't been so extreme. So there are some kinds of bugs that are much easier to see if you don't use extreme data. Extreme data testing can be very expensive. It might be too difficult to do it. You might need a big hefty server or 100 servers to simulate the extreme situation. And maybe you just don't have the ability to do that right now. It might not be worth finding a bug that happens only in extreme cases. Maybe that bug is very rare. Maybe if somebody is going to dump 1,000,000 characters into a little text field, maybe they should expect that some strange thing is going to happen to them. So it's not necessarily true that if I want to find every bug and I want to find every important bug, that the best thing to do is to test with extreme data. So that's what it means when I say this is a heuristic. It's a suggestion. It's a pattern that we should keep in mind using extreme data. And we're going to do some of that. Here's another heuristic. Use a link checker. When I recently revised my website, I used a link checker. I used this particular link checker. It's free online broken link checker. And that's because I know that it's easy to have links on websites that are broken because you're changing things around. And in the course of developing my website, it's easy to see a situation where at first the links are all fine, but then I decide I want to change something, and whoops, I accidentally broke something, right? So we use a link checker to see that those links aren't broken. Now, that is a heuristic. Use a link checker to find broken links is a heuristic. It's not guaranteed. So I actually ran this broken link checker when I was developing the site, but in order to prepare this presentation, I decided to run it again last night. So I did, and here are the results that I got. Well, that's a lot of broken links, and it goes on and on and on. There's something like 60, 70, 80 broken links, a lot of broken links. But most of these are not bugs. They're not wrong, because most of these are in comments. And as comments, I don't care, because these links are put in by the people who made the comments. And their addresses change and their websites change, and I don't need to keep these links live. They're not part of the content of the site, really. Besides, I don't know how to fix the links in many cases, so I just don't care about this. I think people expect to find broken links in comments anyway. So the link checker is wasting my time. It's a heuristic. It's not guaranteed to solve my problem. However, 2 of these are actually broken links that matter to me. And I was surprised to see this because I thought I had fixed all these. One of them, strangely enough, was my James Bach full day workshop I'm going to be doing for the testing tribe in June. And I don't know how this link ended up being wrong. I must have gotten the link by going to the test tribe site, and then later it was changed. Mahesh gave me a link. He gave me the correct link, but this was the link I used. So now it's correct, Mahesh. It's pointing to the right place. So hey, the link checker actually helped me. But there's another class of broken links that this tool can't detect. It can't detect links that go to the wrong place. It can't detect a link which doesn't result in a 404 or a 500 or one of the other bad response errors. A link that responds with a 200, it just ignores that, even if the link has gone to the wrong place. So I'm going to have to hand check my links in order to detect that kind of problem. And again, that's what I mean when I say that this test tool is a heuristic. That's also what I mean when I say you can't automate testing. What I've automated here with the link checker is one form of output checking. This particular form of output checking has been automated, but it's not automated testing, because testing is a process driven by human judgment and human skill. And only when I bring that judgment and skill here does it become testing. Okay, well, that's my presentation. Not too long, I hope. Mahesh, you can call for questions. Oh, wait. I have one final slide. This is my big summary slide. Okay, I forgot about this. So I want to say this is the secret to my success. As I look back over my career, I think I've done pretty well. I feel successful as a tester. I've been hired to do some exciting things over the years. So in order to do that, I created a mental model of software testing, which I turned into a formal model. I used that as a heuristic for helping me rapidly analyze any testing situation and know what to do. I then used deliberate practice with my testing model. I have built a lot of experience doing that. I do use procedures, but I use them heuristically, knowing that they might be wrong, they might need to be changed or thrown away, because I know they're heuristics. I supervise my own work and occasionally the work of other people. I don't often get supervised myself, but I don't need it because I'm already a competent tester. So I apply many methods of self-education, many different ways of regulating my work so that my work is good work. But it's all founded on the idea of mental models and heuristics. And I hope that by raising your awareness about this, you can start seeing heuristics all over the place around you and begin to let go of this feeling that you have to have procedures. You have to have rules. You have to follow the rules. You have to have best practices. You should let go of that. That's a childish attitude. We need to grow up and realize that we are responsible technical people. All right, that's my big summary. So now I'm done. And Mahesh, you can call for questions. Now, if you want to type questions into the chat window, I am looking at the chat window right now. And you know what? I can just bring this chat window right in here. I don't think I can make this any bigger. Oh, look, I can make individual bits of it bigger, but can't seem to make the whole thing bigger. So I'll just read this. Can we also say that heuristics are also a way to explore the problem domain better? Well, of course, you can have, there's two ways, in, at least that is the case. First of all, you can have heuristics that are heuristics for exploring the problem domain. You can have search heuristics, exploration heuristics, for instance. That's one thing. The other thing is that having the attitude and the understanding that your problem solving behavior is driven by heuristics allows you to explore more responsibly, because you realize that it's down to you, that you are the searcher, that you are the practitioner, that it's up to you to deploy your heuristics, that your heuristics don't operate independently of you. Does heuristics and oracles have to go hand in hand? Well, an oracle is a means by which you recognize a bug that you have revealed. When a bug is revealed to you, you might not recognize it. It's visible to you, it's detectable, but you might not notice it. You might not recognize it if you don't have the right oracle. So an oracle is a way to recognize a bug. All oracles are heuristics as well. So you could say an oracle is a heuristic for recognizing a bug. So definitely oracles do go hand in hand with heuristics, because oracles are heuristics. But not all heuristics are oracles. There are many heuristics which have nothing to do with oracles. But that's the way to understand that. All oracles are also heuristics, but not all heuristics are oracles. So another heuristic that I want to mention here, while I'm waiting for somebody to type something else into the question box, is the one of the most useful heuristics that helps me explore things, helps me organize my work. I call it the alternation heuristic. The alternation heuristic suggests that if I am pursuing any strategy, that I should alternate between several different approaches to solving that problem. So I should use one heuristic for a while and then switch and use a different heuristic. So for instance, when I'm learning to use a product, I will sometimes read about it and sometimes play with it. I alternate between reading and playing and talking to people and reading and playing and talking to people. I don't just play and I don't just read. I alternate. How to avoid cognitive biases when working on heuristics? Well, that's a good question, because you could say that heuristics are biases. A heuristic is almost another way of saying bias. Obviously, a heuristic is going to nudge you in one direction instead of another direction. It's a bias. It's a bias to solve a problem in a certain way. Now, cognitive biases are biases that are built into the way that we think as humans. And the origin of cognitive biases is heuristics. In other words, the reason that we have cognitive biases is because our brains are using shortcuts. They're using ways of solving problems that are less expensive than perfect reasoning. They're faster than perfect reasoning. Our brains aren't even capable of perfect reasoning in certain respects, because that would be too expensive, too difficult. So how do you avoid cognitive biases when cognitive biases themselves are a result of the heuristics that by which the human minds work? And the answer is, or I should say an answer is, become aware of the different kinds of cognitive biases, periodically review those biases, and ask yourself if one or more of those biases might be afflicting you in a bad way. And then you try to consciously compensate for that bias. So I try to do this. I try to for instance, this is an important thing when I'm dealing with Indians. Indians speak English differently than I speak English. I'm a native English speaker, so naturally I think I can speak English pretty well. Now, I'm aware, though, that Indian English is different than American English, and that somebody in India can be speaking English correctly in an Indian manner, but that still is different than American English. And that causes me to have a bias, because I will listen to an Indian person speaking English, even if it's correct English from an Indian perspective, and I will think, that's bad English. That person is not very well educated. I know that's wrong, and I know it's a bias, but because I'm aware of this, I periodically remind myself when I am talking to an Indian that they're not necessarily speaking wrong just because they're using words in a different way than I would. And it helps me to have patience and to recognize that my own way of speaking might be unfamiliar to you. So awareness and patience and tolerance are some of the ways that we avoid the worst effects of cognitive biases. But we can't avoid all cognitive biases because we would shut down our thinking. It would be too expensive to think without using some of the cognitive biases. Can we have an example here for better understanding? All oracles are heuristics, but all heuristics are not oracles. Okay, I'll give you an example. Here is an oracle. The oracle is, if you see a screen and it's a blue screen and there's white text on it, and the white text says, Windows has failed. That's called a blue screen. If you see a blue screen, well, that means there's a bug. Okay, that's an oracle. The system should not give you a blue screen. Now, this is a heuristic. It's a heuristic for several reasons. One reason is that the blue screen may have happened not because of a bug in your software. It might be a failure of your hardware, or it might be a failure of some other software that's not related to what you were testing or what you were doing when you were testing. So it's certainly a problem, but not necessarily a problem that matters to you. It may also be a prank. There's a screensaver out there which puts a fake blue screen on your screen whenever the screensaver triggers. It's a terrible prank to play on someone because they're going to restart their system and lose all their work. But I have played this prank on people. So it's probably not happening, but it is still possible that a blue screen could not be real. So that's what I mean when I say it's a heuristic. It may not represent a bug, but it's certainly an oracle being some means of recognizing a bug. If you see a blue screen, then something wrong happened. But all heuristics are not oracles, because you can have, well, for instance, a hammer. I've already used that example. A hammer is for driving nails. The hammer doesn't detect problems. The hammer is not a method for noticing or recognizing a problem in software, but it's certainly a heuristic. It's a way of solving some problem, just not solving the problem of, is this a bug? Does the Turing heuristic come under oracle, or is it another technique? Well, there is no one Turing heuristic. There are many Turing heuristics. A Turing heuristic is a heuristic for coverage, not for oracles. So when we say a tour, we're talking about some way of exploring the product, some way of navigating through the product. Examples of tours are a complexity tour, where you try to find all the most complex parts of your product. A user interface tour, where you try to visit all of the bits of the user interface. You can have a happy path tour, where you visit all of the elements of the product that make it what it is, that you think that most users would do under normal circumstances. We can imagine all kinds of tours. And what tours are trying to do is get you to systematically see what the product is. Now, that's not an oracle, because an oracle isn't about seeing something. An oracle is about recognizing something. You can see somebody, but not recognize that person because they're in disguise or because you've never met them. What is the best stage in the testing life cycle to refine your heuristics? There's no best stage in testing life cycles for refining heuristics. I am constantly refining my heuristics. It's an ongoing process. anytime you're using heuristics, then you can be refining your heuristics, and you are always using heuristics. Now, if you're not aware that you're using heuristics, that's one thing, but you should become aware of the heuristics that you're using. One way to become aware of the heuristics you're using is just for the next 5 minutes, watch yourself as you move around the world and notice when you solve a problem. So in a few minutes, you're going to get up from your chair and you're going to go and leave the room. And you can ask yourself, well, how did I know? How did I solve the problem of getting out of this room? Oh, well, I saw a door and I went to the door. So is that a heuristic? Look for a door when you want to get out of the room? How did you open the door? Well, I grabbed the handle and I turned it. Well, is that a heuristic that when you see something that looks like a handle, try turning it? How did you know what direction to turn it? What you'll find, as I found, is that if you just stop for 5 minutes and notice your own behavior as you work, you'll see that you're constantly solving little tiny problems and occasionally solving bigger problems. And those patterns by which you are solving those problems, you can learn to identify them through practice. And then you can name them. And when you name them, you make it easier to reuse them. Okay, I'll stop the share. I'm stopping the screen share. And now I'm trying to get my chat window back. Where'd the chat window go? Uh-oh. Dang it. Now I can't find my Zoom. Have I just accidentally cut off the... Oh, there I am. I'm all okay. I'm trying to find my chat window. I can't find it. It's gone. Mahesh, are you there? Am I still on here?
Hi, James. Yeah, we are able to see and hear you.
Okay, I am now trying to think what heuristic can I use to find the chat window again, because it's completely disappeared. So I use the Alt Tab to tab through all the windows that are open, and none of them are Zoom. So that didn't work. I'm looking at my tray to see if it has become a hidden window in the tray. Ah, maybe that's it. No, but that's just that is a sign-in window. Interesting. Zoom is giving me a sign-in window. It's asking me if I want to sign in or join a meeting. When I click close on that, it says, do you want to leave the meeting? I'm like, no, I don't want to leave the meeting. I think this is a bug. My oracle is I should be able to see the Zoom chat window. So you're going to have to read me the questions, Mahesh, because now I don't have any visual. Can you see my video? Oh, now I can't even hear you.
Yes. Yeah.
Can you see my video?
Yes, you're on.
All right. So I can't see the video or anything. So read me the question. Are there any more questions? Read them to me.
Yeah. So Jocelyn is asking, is it better to plan or set an heuristic as a group or as an individual?
Well, there's no better or worse. Both things can happen, and of course, you're always managing your own work as an individual, so you will use your own heuristics. Whether you're aware of them or not, you're going to use them. But I urge you to become aware of them and to list them and name them, the important ones as you work. And that's what I do, and that's what I put in my classes. But of course, you can also discuss heuristics in a group setting and talk about the various test techniques that you are going to use, the various approaches to testing that you're going to apply, and all of those are heuristics. So it's not one or the other. They're both interesting modes. And let me put it this way. It really helps to talk about your heuristics with other people, because as soon as you do, then they can suggest better heuristics. They can suggest different heuristics. They can suggest contrasting and opposing heuristics. And you might reach a deeper understanding of the work.
Okay. Yeah. So Sandeep's next question it's a bit lengthier one, so I'll try to read it slow. How about, for example, such language, Indian versus American versus UK, in bracket that was, specific biases happen while requirements, interpretations, discussions, and my awareness didn't work at that crucial time of introducing bug into the system. What are your views on awareness and correcting continuously but still bugging customers versus, in bracket he's saying correctly, hardening my brain towards a solution of a bias and make things better?
Okay, well, if I understand that question, it seems to have to do with having misunderstandings and overcoming those misunderstandings over time on the job as you work. So you may have a misunderstanding of a specification, and you need to get over that as fast as possible. The problem is you don't know what you've misunderstood. You read something and you think you've understood it. Well, I use a variety of heuristics for that. And one of them is I periodically have conversations where I question the requirements document. I question the specifications by talking to the person who wrote it or someone who is implementing it. But questioning is not enough. Another method that I use, a heuristic that I use for discovering that I've misunderstood something, is to explain the thing that I'm trying to understand to the person who already knows it. So I will explain what I think the requirements mean to the designer who wrote the requirements or to the developer who implemented the product. I'll say, this is what I think. I think what you're doing is this, this, and this. And then they will correct me if I'm wrong or if I've forgotten to say something. And so I can come to a better understanding in that way. A third way that I can come to an understanding is through reporting bugs. Because if I report a bug that isn't really a bug, because I've misunderstood what the product is supposed to do or not do, well, then I'll discover that I was wrong, because the people will react to the bug and they'll say, oh, that's not a bug. So over time, I ought to get a better and better view of what's going on. Yet another heuristic I use is to rewrite a specification in my own words, or to make a diagram of that specification. And by doing that, again, someone else will look at it and they may realize that I've had a misunderstanding, or I may realize that I don't understand something when I try to make an alternate representation of that thing. So those are some ideas.
Okay, great. So Jocelyn is asking, can we live without mind maps if we have a good heuristics in place?
Well, sure. I mean, mind maps aren't any more of a best practice than anything else. A mind map is a helpful tool, but you can use other tools. You can use, obviously, there are other ways to write something down than to use a mind map. You can use other kinds of diagrams. There are many other kinds of diagrams. You can keep it all in your head, and in fact, you do keep it all in your head when something is very, very new. Creating an elaborate mind map for something that is changing a lot might be a waste of time. So, a mind map is just one interesting method. I could show you a mind map that's so large it's completely unusable. And so the only reason I used this mind map is to help someone understand how complex something was. So I created this very, very large mind map. But the mind map itself is very difficult to use. So instead of using a mind map, we moved all the information over into a spreadsheet and used that instead. A spreadsheet was much more manageable for something that has 800 elements in it.
Yeah. So the next question is from Lara. I hope I'm pronouncing the name right. Is there any paper or article on heuristics that you use?
There's a book. There are a number of books that discuss heuristics in a way that helped me understand them. The first book I read that really turned the light on for me and made me understand the importance and power of heuristics and why I should be thinking in those terms was a book by Jerry Weinberg called Exploring Requirements, Quality Before Design. Exploring Requirements blew my mind because what Jerry said in that book is there's no way to be sure that you have the requirements correct. But there are many heuristics to help you discover what the requirements of a product should be. So we can use lots of heuristics, but there's no one best method. That's when I first learned that I should be thinking about heuristics. Then there was a book that helped me become mature in my understanding of heuristics. And that book is called Discussion of the Method. I actually have that book here. It's by Billy Von Cohen. It's called Discussion of the Method. And this book is written by an engineering professor. He's not a software tester, but he's a professor of engineering at an American university. And he makes the point, and he persuaded me, that everything in engineering is a heuristic. It's all heuristics. And what really matters is that you have technical skill and judgment. So you know how to apply these heuristics. So until I read Discussion of the Method, I didn't have the attitude that basically everything is a heuristic and we should think about it that way. But Cohen convinced me that that's a superior way of thinking and that's a more responsible way of thinking. So I definitely recommend that book. Now, apart from that, there are many, many, many journal articles on the topic of heuristics. And some of them I like, some of them I think are misleading. One of these days, I'm going to put together a bibliography on heuristics and put it on my website with my other bibliographies, but I haven't gotten around to doing that.
Okay. So James, in case you have the Skype open, I am copy pasting the questions there so that we don't lose any context as I'm narrating.
Oh, okay. I have Skype open.
Yeah. Can you see my message there?
Yes, you say, what are some of the recommendations for evaluating your heuristics? Okay. Well, I have a few ideas on that. First of all, a heuristic needs to be helpful. You don't want a heuristic that is hurting you more than it's helping you, but that's not enough because you might have a variety of heuristics that all are helpful, but some might be more helpful than others. So what we need to do is we've got to try out the heuristics. We've got to compare them. We've got to break them down and understand why they work. And so that's a recommendation, is you should know why a heuristic works, not just that it works, but why is it that it works. So for instance, I just used Alt-Tab to try to find the Zoom process. And the reason why that's supposed to work is that every visible window on Windows is supposed to be made available through the Alt-Tab process. Now, in this case, I was not able to find the Zoom window again, which suggests to me that there's a bug in Zoom. But that's only something that comes to my mind because I have experience using Alt-Tab, and I can't recall a time when I'm not able to find a window of a running application by using Alt-Tab. So the fact that I'm not able to find that here, to me, strongly suggests that Zoom is gone. Except that Zoom is not gone because you guys tell me you can see me and you can hear me. So that tells me that just the window process of Zoom has died. So I am only able to do that reasoning because I understand some of the dynamics about how Windows itself works and what a Windows process is and all that sort of thing. So if you're going to evaluate your heuristics, you have to evaluate them based on understanding their underlying dynamics, understanding the embedded technology and problem context behind them. For instance, let me give you an example of something that I give to my students as something I have them analyze. There is a principle that Glenford Myers proposed many years ago, where he said that the number of bugs that are left in your product is proportional to the number of bugs you've already found. He was saying that if you found a lot of bugs in a product, there are probably a lot of bugs that you haven't found. And conversely, if you test and test and test and you don't find many bugs, there are probably not very many bugs to find. Okay, so that's a heuristic. That's not a guarantee. We don't know for sure. But you need to know, if you believe that heuristic, if you think that's helpful, you need to know why that should be the case. Why is it that the more bugs you find, the more bugs there probably are? Now, I'm not going to tell you the answer to this, but I think you should think about it. And I think if you think about it, you'll realize that there's some assumptions that Glenford Myers is making, and you should become aware of what those assumptions have to be in order to make his heuristic useful. So that process is an important process by which I evaluate a heuristic. I model the heuristic. I try to identify its hidden assumptions. I try to run mental experiments and sometimes physical experiments to see if there are exceptions to this heuristic. Where are those exceptions? And that's an ongoing process. Do you think there are drawbacks of using heuristics? Well, of course there are drawbacks of using heuristics. The heuristics might fail. It might lead you the wrong way. A heuristic might tell you to stop testing when you should continue to test. It might tell you to continue to test when you should stop testing. It might tell you there's no bugs here when there are. Of course, there are drawbacks of using heuristics, but you're stuck. You have to use heuristics because what's the alternative of heuristics, Jessley? The alternative heuristics is to use infallible methods, but you don't have any infallible methods. That's the bottom line. You don't have an algorithm to do testing, so you're stuck. So the question is, are we going to use heuristics responsibly or not? That's really the choice we have. The carpenter is going to use a hammer because he doesn't have an infallible method of driving nails. So you're just going to have to learn to use a hammer really well, and you're going to have to learn to tell when the nail isn't going in correctly and then learn to correct that. Mayak says, as heuristics do not guarantee a solution, it becomes a bit tricky to evaluate them. Well, of course it's tricky to evaluate heuristics, but heuristics aren't tricky to evaluate because they don't guarantee a solution. I mean, that's not the reason they're tricky to evaluate. They're tricky to evaluate, generally speaking, because they don't live within a formal system. If you have something that lives entirely within a formal system, then it becomes possible to evaluate them formally and to know exactly how good a heuristic can be. But not many heuristics that you find are going to be living inside a formal system because you're not mathematicians and you're not evaluating mathematical heuristics, probably. You're probably a tester. And so your heuristics live in the world of humans and the messy world of servers that sometimes work and sometimes don't, and that sort of thing. So yeah, it's tricky to evaluate them, but that's just life. I understand you don't really recommend using test cases. I do think test cases are an overused heuristic and with a lot of downsides. Yes, that's true. But still, because majority of companies have those as part of the process, how do you think testers can leverage heuristics better to make their test cases better? Well, you can have test cases, but not be a slave to them. I mean, I suppose that's my primary recommendation, is don't take your test cases too seriously. If you're forced to write down test cases, you certainly are not being forced to think that test cases are testing and test cases are the backbone of testing. You don't have to think that, even if you're going to write down test cases or put them into a test case management system. So all over the industry, there are testers who use test cases, sort of. They document them, but then they don't necessarily follow them. Or when they do follow them, they follow them very loosely. They improvise on them. They don't follow them slavishly. And I also recommend that you do things outside of the test cases. You interact with the product, you experience the product, and you explore based on your experience, which is going to be something that's generally speaking outside of test cases. Finally, you can call something a test case, but that test case can be very broad. I have seen people have, quote, test cases that are simply statements that say, test this thing. You know, that's their test case. It just reminds them to test the report generator. Well, that I wouldn't call that a test case. I would call that a reminder, but they call it a test case. So test cases can be all kinds of things, and you have some flexibility in. You probably have a lot of flexibility in what you are calling a test case. So I recommend using that flexibility to make test cases as useful to you and as non-silly as possible. Okay, so Bangalore workshop. Oh, are you talking about, I should mention that we're doing the one-day workshop? Okay, I'll do that. The Testing Tribe is hosting a workshop that I'm going to be doing, a one-day workshop. It's in June. It's in late June. I just fixed the link on my website that goes there. It's on the Testing Tribe website. And what we're going to do is I'm going to bring a product that I'm going to challenge you to test. And then after you test it for a little bit, I'm going to stop you and we're going to talk about how we're testing it and have a discussion, maybe have some arguments about the heuristics we're using and what is a good way to test this. So it's going to be a workshop, and I would love you to come to this workshop and try to test this thing and then try to argue with me about testing. And I guarantee you'll get sharper and you'll get better at testing through this social process of testing and then reviewing what we did. And then I'll show you how my mental models of testing relate to your mental models of testing. Clara asks, do you have any recommendations for useful systems thinking books other than Weinberg's Introduction to General Systems Thinking? Yes, Weinberg's Introduction to General Systems Thinking is the single best book, although it is rather hard to read. It is still fantastic. There are other books on it. There is a book called Seeing Systems that I want to recommend that is much easier to read. It's a book really about systems thinking about humans, about human organizations, but it's very well written. It's by a guy named Barry Oshry. There are many books about general systems thinking that don't have the title General Systems Thinking in the title. One other that I can recommend off the top of my head is called The Logic of Failure. The Logic of Failure by Dietrich Dornier. I found that a wonderfully eye-opening book. It's a book about system simulations that people are asked to manage and how they mess up these simulations and cause failure because they didn't understand the system that they were trying to control. So it's a wonderful book about how people mismanage things because they have bad mental models. Are test cases fallible? Yes, every test case is fallible because a test case is a bid to find a bug, and it may not find a bug. You only write a test case because you want to find a bug. There's no point in writing a test case if you think it's not going to find a bug. So you write a test case because you say, if there is a bug in this part of the product, and I think there might be, why then I want to find it. So a test case is a kind of guess. It's a kind of a gamble. So test cases are written keeping functionalities in mind. So do you think this fails? Well, yeah, of course it can fail. It can fail to find a bug that is in the functionality that it's supposed to be testing. That's not to say that it might also succeed in other ways. I mean, a test case is almost always going to successfully exercise the product in some way. But is it exercising the product in a good way? Is it exercising the product in a cost-effective way? Are your test cases mostly wasting your time? Or are they mostly helping you use your time well? you need to work on that. You can't just assume that because a test case is written by somebody that it is automatically a good use of time. There might be much better test cases than the ones you're using. So, yes, a test case is fallible. Every test case may not achieve its goal. The goal is to find important bugs if they exist. And it may fail to do that. You can't tell me that every test case, that any test case is guaranteed to find every important bug that it is designed to find. But of course, some test cases are much better than others, or carry much more likelihood of finding an important bug than others. You have to think through the logic of the test case to decide that.
Okay, so James, I think that's pretty much what we have in questions.
Okay, good. Thank you very much for having me. And I'm sorry that Zoom died on me, but I'm glad it didn't completely cut me out. And I look forward to coming to India next month. Hopefully, I'll see somebody there. It's been not 12 years. It's been 8 years. 7 years. 7 years since I've been to India. So I'm very much looking forward to eating that incredible food again.
Yeah, we look forward to host you, James. And thanks again for saying yes for doing this webinar series, which we recently started. And I believe it's pretty early for you in the morning.
Yeah, I'm going to go back to sleep.
Okay.
I got up too early.
Yeah, so we wish you a wonderful day ahead. And because you cannot see the chat window, so I'll just narrate.
I'll
like
just wait.
people are thanking you for all the time and wisdom. So
All
thanks
right.
again for being with us, and
All right.
I look forward to meet you again in the June.
All right. Good luck, everybody.
Bye-bye. Thanks, Tribe. So I'm ending the video now. Thanks for attending, and wish you all a very good night's sleep. Thank you.